Okay, I'm going to speak about RxJS, and when I applied with this talk, I thought, okay, it's advanced topic, it's interesting, but after 2 previous talks, it's like basic stuff. You can learn it from Stack Overflow, which is fine. And before we start speaking about what is RxJS and how to implement it, let's answer the question, why use RxJS at all? What is the use case? In fact, in front-end applications, there are some areas that took a lot of attention from front-end developers. And these areas are usually connected with user input and API calls. What's common with them? In fact, it's concurrency. In both cases, we're dealing with asynchronous behavior, and async is hard. Of course, we have promises, but promises still have a limited functionality. And RxJS provides some nice concepts to deal with async. It's not a silver bullet, but it's good to know. Now I can introduce myself so you can know some more information about me, except like driving with Sarah in Romania. My name is Natalia. I'm a Google developer expert in web technologies. I'm a Vue community partner, not a core team. I'm in a docs team, and it's very complicated. But I work on Vue, and I really like this framework. And I work as a senior front-end engineer at GitLab. So what is RxJS? It's easy to see that RxJS is an abbreviation, meaning Reactive Extensions Library for JavaScript. JavaScript part is clear, I hope. We're at JavaScript conference. So what is reactive extensions? Let's look at official documentation of ReactiveX, and it's stated that ReactiveX is an API for asynchronous programming with observable streams. Wait, what? What does it mean? Let's try to destructure this spell and start with streams, because understanding ReactiveX is thinking in streams. Stream is not something alien. Stream is just a collection of events. So when user is typing on the keyboard, it's a collection of key down events and key up events as well. When we are moving the mouse, it's a collection of mouse move events. When we have an API call, again, it's a collection of sending request and resolving it. Everything is a stream. And streams are a collection of events like objects and arrays in JavaScript. And we have an awesome library to deal with arrays and objects. It's Lodash. So you can think of RxJS as Lodash for events. It provides plenty of methods to deal with observable streams. And the core concept of RxJS, as I just mentioned, is observables. Let's have a look at a place where observable should be in JavaScript. So here is a table representing JavaScript primitives. And for singular synchronous primitive, we have just a value. Number, string, boolean, whatever, just a value. For plural synchronous primitive, we have an iterable of value, which is just an array. For singular asynchronous primitive, we have a promise. And at some moment of time, promise is resolving to value. But we don't have a primitive for plural asynchronous. And it's a place where observable should be. In fact, there is proposal to TC39. It's stage 1 right now, since 2017, which doesn't give us hope it will be in ECMAScript at some point, but we have a library to deal with it, so it's fine. Let's compare observables to promises, just to understand the difference. So x-axis here is a time. At some moment of time, promise will either resolve to value or rejects, and throw an error. And it's a moment where promise is completed. You can't do anything with promise after this moment. Let's have a look at observable. Observable will emit values over time, and at some moment of time, it completes as well. But this moment can be completely separate from the latest emitted value. And also, any moment of time, observable can throw an error. What is observable under the hood? Nothing specific, it's just a function. Like a lot of yay! More functions. Now it's observable functions. This function takes observer as a parameter and returns cancellation logic. What is observer? Observer is simple, it's just an object, not a function, sorry, but it has 3 methods: next, error, and complete. Next method is called when observable emits next value. Error, obviously on error, and complete when it's completed. And we can create an observable with a constructor function, which is looks really complicated, but nothing special. We are taking observer and call observer methods whenever we have data, error, or complete. In fact, this complex thing will never happen with RxJS because it has a lot of methods for creating observables without this huge structure. Observables are lazy. That's why I really like them. They're just like me. What does it mean, lazy? Observable won't emit any values until it has at least 1 subscription. To understand what's going on, let's think about YouTube video. YouTube video is a stream because it emits frames as events. And imagine there is a YouTube video and nobody is watching it, nobody on Earth. Nobody just clicked play button. This observable won't emit values. This behavior is also named cold observable. Observables can be converted to hot ones, emitting values without subscriptions. Let's imagine a YouTube live stream. And there is a streamer somewhere on Earth, and nobody is watching his or her stream. Been there, done this. It's very sad, but still. Even if nobody is watching the stream will emit values, will emit frames. This is called hot observable. But by default, they are all cold and lazy, and they need subscriptions. Subscription is created with a simple method of observable named subscribe, and we're passing our observer at this moment. Very important moment, if you create a subscription, observable will emit values until you unsubscribe. So if you don't need your observable anymore, please unsubscribe. Don't make it work, it's lazy. Now it's like functional part of RxJS, it's operators, like for Lodash. RxJS has a lot of operators to transform, filter, combine, and alter streams, and when I say a lot, it's a lot. Good thing, you don't need to remember all of them. RxJS has an awesome documentation at learn.rxjs.io, so we go check it. And I need an example, of course, and I won't work with API calls today, but I will work with complex user input. And what can we imagine as an example for complex user input? Games. In fact, when we're playing games, we have a lot of interaction, a lot of different options to interact and to create input. And I have a great example. Please make a sound a bit louder. Oh my God, I'm staying on stage with Moonlight Sonata on the background. My mom should be really proud with this. It's a game built with Vue, Vue, and RxJS. In fact, I'm just putting space all this time, but you need to do it with the right temp, and it will play music. So if you're a bit bored and don't want to listen about RxJS anymore, go please check the game, but make a sound a bit quieter, because talk. And I don't have these amazing skills of nice animations. I'm not Sarah Dresner, sorry. That's why I will build nerdy stuff from 1876, like this. Bricks, nice. So let's go to demo time. Yeah, I have no idea what I'm doing, but let's try to create a breakout from scratch. Well, almost from scratch. Okay, let me know if you see the code nicely. a bit, okay, I will make it a bit bigger. Zoom in. Better? More? More, okay. And more. Yay. Okay, I hope you can see it. Nice. And I spoiled the question, but okay. Now we need to define our source streams for the game. So what source streams can you imagine for Breakout game? Any guesses? Yes, first one is actually user input, but we have one more. Time, right, we need ticks. We need to update our image over time. And let's try to create this stream. Okay, this is a game. Should be a game. So let's create our first stream. Let's create ticker. And we should emit values over time. And for this, RxJS has a method called interval. And I have a magic constant, ticker interval, which is going to emit values for achieving like 60 FPS. And let's have a look how it works in our console. We will subscribe, have a tick, and show it in a console. Yay, arrow functions. I feel smart now. Okay, it's very small. I will try to increase it a bit. As you can see, in the console, something is happening. In fact, we're emitting number every 0.017 of a second. Nothing fancy, just numbers. Let's try to add some more things. First of all, we need to think about animation frame, because 60 FPS is nice, but it's not always achievable. So let's add a scheduler here, and it will define when actually we have a change of a frame, and it will emit a value only after this. So I have animation frame scheduler. In fact, if we have a look, nothing changes, but it's just a bit slower, because I can't achieve 60 FPS right now. Great. Now we will need to think, what do we need to have here? We need to calculate a delta time between previous tick and current tick. And to do so, we need to transform our stream a bit. In RxJS, all methods are pipeable. It's very similar to a chaining, but all pipeable functions are pure functions. Like, functional programming is great. It's just easier and more clean. And we are reaching our first operator. It's map. It's not JS map. It's not array prototype map. It's map from RxJS. It does pretty much the same as array map, but with observables. Now we have an observable. We don't need anything from our interval observable, but we are going to return a new object every single tick of time. We will have time, which is just date now, and delta time, which is just null for now, because we are just transforming our ticks to these objects, not calculating delta time. As you can see, we have date now emitting, and now we need somehow to check the previous value of the date and new one. And it's really a tricky moment, because usually you need an external state for this. You need to store the previous value somewhere to calculate it. But the RxJS is magical, and it has scan operator. And scan is similar to reduce method on array. It will take previous value and new value, and will operate with them, but also emit values every single iteration. So now we have previous and current, and we are going to calculate delta time. So right now time is current time, And delta will be current time subtracting previous time and divided by 1000. Okay, now you can see we have this delta time, and it will be used in our helper functions to update the picture. And we can remove the subscription, we don't need it anymore on our ticker. Now let's move to the second stream, user input. Let's create an input. And I forgot to say, you can see this $sign. It's a common convention to add $sign when you're naming observable streams, just to distinct them from the const values. So input, and we need to create it again. We will use RxJS method from event. We will take document key down event, and we'll do something with this. What do we actually need from user input? We need to find if user is pressing left or right arrow and move our pedal with this input. So let's add a simple switch on event key code. So in case we have pedal keys left, and this magic pedal keys is just an object where left is 37 and right is 39, we will return -1. Why -1? Because we're moving our pedal on x-axis, so we are going to move it left. We are subtracting. Obviously, in case of pedal keys right, we have what? 1. Nice. And for default case, if we're just pressing some random button, we will return 0. Okay, let's subscribe to it and see what's happening. Yeah, I love console logs. Okay, now we are trying to move our pedal. No pedal exists so far, but we are just emitting events on every key down. And if I try to push some random keys, it's 0. Okay, now we are ready to create a pedal. And pedal is depending on 2 streams, because we need to move it over time, so we need our ticker stream, but we also need count on user input, like where should it move. So we are taking our ticker, and here is the first magical operator. It's not that obvious, it's with latest from. What it actually does, we're taking the first stream, and we will emit new values whenever first stream is emitting a value. But we also will take the value from the second one. It's a really interesting moment because RxJS has a similar operator named combine latest, which takes 2 streams, but it will emit values whenever any of these streams emit a value. Here we are emitting values only when ticker emit values, so like 60 times a second. And we take our input here, and we're going to do some scan again. We will take a previous one as a position we already have, and we have our ticker and our, let's name it direction. It's not an input already. And of course, we need more brackets. And we're going to call our helper function move pedal with 3 parameters. position, ticker, and direction. This magic method is just calculating the position depending on delta time and move it. So let's try to subscribe and more console logs. Everything is cool instead of not a number. Why? Why it's not working? Because we have this position and it's a previous value. And for the first iteration, it's undefined. Our pedal doesn't know the initial position here. So let's provide it. It will be our canvas width divided by 2. So it's a center. Okay, now we have coordinates of our pedal, and we are ready to actually draw something. No more console, hopefully. If it won't work, we'll be a console log again. Okay, let's try to create our game loop here with our pedal. We need an update function, and it will take our pedal as a coordinates. And first of all, we need to clear the whole game. So I will do just context clear rect. So it will clear the whole field of the game. And let's draw pedal. And before this, I want to use 2 more magic methods. It will be draw title and draw controls. And these 2 methods will just draw some text on the game field. Let's make it a bit bigger as well. Yeah. Now we are going to create our main subscription, which is a game. And here we are going to combine our streams, because we need to emit new values whenever we have a new tick or user moved pedal. So we are combining our ticker and our pedal as well, and we are subscribing to them. And we don't need ticker in update function, so only a pedal. Great. And we are calling our update. Okay. So yes, it's moving, but we have the first issue. I'm not typing anything, but it still moves. Sometimes it's good if you're really lazy, but we need somehow to stop it. Interesting moment. If right now I will push any button, not an arrow, it will stop, because by default we're emitting 0. So probably we will need to emit 0 also on key up event. Let's go back to our input and merge 2 streams here. So first is our familiar key down. Second is very similar. It's again from event. It will be document, key up, and we will just emit in 0 no matter what. Okay, back to game. Cool. I'm moving a rectangle. Great feeling. Now we need, like with an owl, yeah, draw 2 circles, now draw the rest of the owl. Now we need to draw a ball and bricks. And I won't dive deeply inside of it because I have 5 minutes. So I have a magic method to draw them all. But we need 1 more stream to be created here. So we have objects. And by objects, I mean the rest of the game. And again, we are working on our ticket stream because it's our game loop base. With latest, from pedal, because we need to take our pedal into account. What about collisions with ball and all this stuff? And again, we have this magical scan operator. And I will just copy-paste all the parameters because there are a lot of them. So I have this huge function to calculate everything. And from previous state, we will need these 4 parameters. And we also have our ticker and our pedal. Great. More brackets. Yeah, I know. Exciting. And we are going to calculate object with all these parameters and also ticker and pedal. But now we are smart and we know we need initial objects. Otherwise, we will have the same as with a pedal. And we have initial objects. Yay. Let's hope no, it's not going to work because we need to provide our objects to update function. So we are adding 3rd string here. And it's objects. And here. And we are going to pass them to update function. And inside of update function, we are going to draw a ball. Also bricks. Not object, but objects. And I forgot to pass them. If you see I'm failing, just don't hesitate to shout out. It's like, yay, you forgot objects. You're going to fail. Objects, bricks. And we also need a score, because it's a game. What about achievements? Score. Okay. Now, crossing fingers, it should work. Okay. Wow. Wait. There is a fail, and you will see it right now, okay? What the hell? Like, game should be over. We need somehow to die. And like, wow. So the thing is, we need to define the moment. I know, right? It's like, it's immortal code, but we need somehow to end the game. And the game is subscription. So we need to unsubscribe from it to end the game, actually. So let's add a condition. If our object's ball position y is more than canvas height minus ball radius, because otherwise it will go under the border, we are going to draw game over. It will just render a text on the screen, nothing magical. And the magical part is here. We need to make game unsubscribe. Let's check it now. Okay. Nice. Game is over. And to be a bit better and to be more kind, we need also to end the game when we have no bricks. Imagine if you just think you're winning, like no bricks and game is not stopping, just continue. Now we will draw something more positive, like congrats, and unsubscribe again. And I'm not going to test it because it will take a lot of time. And also the lunch is ahead, so it's like everyone with food, but okay, game over. And if you want to check this game and all the magic methods I had here, I have this repository for the breakout. And thank you.